students, welcome to Concept Builder series by Vibrant Academy. Today we will talk about examples from motion and gravity. Let's talk to the case where an object is projected vertically upward. It takes time t1 to reach to maximum height and time t2 to return back to the same point. And out of the four options, which one is correct? If we analyze the case, it appears that when the object is moving upward, it is moving against gravity, so it may take more time. And while coming down in the direction of gravity, it may take less time. So it appears that T1 should be greater than T2. But the answer is here, T1 is equal to T2. Now the question arises, why it is so? When it is moving against gravity, it should take more time. But you are getting both times are equal. Let's try to analyze. If you take the case when it is moving up, when moving upward, what do you find? Speed was given u. At maximum height, speed becomes 0. That means at maximum height v0. So if you write here u equal to, or you can say here v equal to u plus at, you get here u equal to gt1. Now you have h equal to ut1 minus half gt1 square. So if you substitute the value for u, you get gt1 into t1 minus half gt1 square. So what you observe, you are getting here half gt1 square. Means t1 is under root 2h by g. Let's take the case of when the object is moving down. When moving downward. In this case, u is 0. And of course, therefore, h will be ut2 plus half gt2 square. So this gives you again t2 equal to under root 2h by g. So what do we observe from equations 1 and 2? Equations 1 and 2 follows, both are equal, t1 equal to t2. So it's very easy to understand why these two are equal. Now let's take the case of air resistance in example 2. Then how does these two times is affected? Now what makes a difference if a resistance is present? Normally it appears that if a resistance is to be taken into account, then it is going to oppose both up and down. So overall there will not be any effect. And hence again answer should be T1 equal to T2. But here student try to understand, if you consider air resistance, then the result is a bit different. Rather entirely different, you can say. And it's very interesting to understand. Time taken to move up will be rather less than the time taken to move down. When the body is moving up, it takes less time, and when moving down, it takes more time. Let's try to prove it. That means your answer should be here now. T1 is less than T2. Again, analyze when moving upward. First thing, let's consider, let A is air resistance, or you can say retardation offered by air resistance. Retardation offered by air resistance. So here, while moving upward, we find A is acting opposite and small g is also acting opposite. Let the object goes to height h. So while moving up, it takes time t1. So effective value of acceleration will be what? G plus a with negative sign. So here, what do we get at the maximum height? V is 0. So we can add here h will be u square by twice g plus a, and if we use the time, it will be u by g plus a, because v is 0, so you could gt, but g effective is g plus a, so you get t1 as u upon g plus a. But you take the case where it is moving down. When moving downward. Now, from maximum height, if the body is returning back, air resistance is again going to oppose in the upward direction. But G is acting still in the downward direction. So effective A will be G minus A. So what do we observe here? In this case, as U is 0, so what do we write? H equal to half G minus A T2 square. Now substitute the value for H here. What you have taken, because H is same when moving upward, moving down, still height is H. So we can replace this H by this formula U square by 2 into G plus A, and is half G minus A to T2 square. If you solve this, you get T2 will be U upon G plus A into G minus A. Now if you compare the two equations, first one T1 U by G plus A, T2 U upon G plus A to G minus A, very clear they are not equal. But earlier it was equal. When air resistance were not considered, they were equal. But now if air resistance is to be taken into account, then T1 is U upon G plus A and T2 is U upon G plus A into G minus A, that is they are different. And if we carefully compare the two, we will find T1 is less than T2. So you can say, therefore, equations 1 and 2 follows. T1 is less than T2. That means time of ascent is less than time of descent. Very interesting result. When the body is moving against gravity, it is time of ascent. It takes less than when moving down in the direction of gravity. Time of descent is more. So dear students, understand that T1 here is less than T2. In case of any doubt in this particular example, continue watching the next video in the same series. Thank you.